Introduction. The class develops the possible failures a vehicle may have depending on the color of the exhaust, and the implications for fleet management. What the colors of exhaust smoke mean today. Polluting emissions from an internal combustion engine. Since the invention of catalytic converters and particle filters, we have become accustomed to the fact that, in most cases, no visible combustion residues are emitted from the exhaust pipe. But this is not always the case. The exhaust systems of modern cars mainly emit carbon dioxide CO2, nitrogen N2, water H2O in the form of water vapor, nitrogen oxides NOx, carbon monoxide CO, and unburned hydrocarbons HC. CO2 emissions are a direct result of the combustion of carbon-based fuels, while NOx is produced by high combustion temperatures that promote the binding of nitrogen and oxygen in the air. Carbon monoxide and unburned hydrocarbons are the result of incomplete combustion processes. Thanks to modern exhaust gas after-treatment systems, such as catalytic converters and particulate filters, concentrations of harmful emissions have been significantly reduced, thus minimizing particulate and carbon monoxide emissions. This is the short answer to why it is difficult to detect exhaust gases without a chemical laboratory today. But what if you could? What if my car suddenly emits unusually high levels of smoke, soot, or vapor? Why does the car in front of me on a hill smell so bad? Blue smoke indicates oil combustion. We will begin with one of the most critical issues. Occasionally, blue clouds or a persistent blue column may emerge from the exhaust of cars. This indicates that a certain amount of oil is being burned in the cylinders. Anyone who has worked with a two-stroke engine will be familiar with the result. The oil needed for lubrication is mixed with the fuel and therefore burned. This creates the characteristic smell of oil and blue smoke. In four-stroke engines, in virtually all modern cars of the last 50 years, this effect is completely undesirable, as clean combustion is not only better for the environment but also optimizes efficiency and, consequently, engine performance. For this reason, combustion chambers are sealed against oil ingress. From above, by means of valve stem seals to prevent oil from seeping past the valves, and from below, by means of oil control rings and piston rings to prevent lubrication from the crankshaft and cylinder bores from entering the combustion chamber. Both must withstand high loads, so wear and tear manifests itself in the fact that engine oil continues to burn. Many years ago, this was a sign of an aging engine that needed at least a partial overhaul. Drivers of cars such as BMWs and Alfa Romeos from the 1970s and 1980s were familiar with the small blue clouds that occasionally appeared in the rearview mirror when they released the accelerator because the valve stem seals were failing again. Today, thanks to modern hardened materials, this is no longer usually a problem. If it does occur, it indicates a poorly treated engine and, above all, inadequate maintenance. Dense blue smoke from turbo engines. A special case arises when engines with turbochargers produce dense blue smoke. This smoke is also connected to the engine's oil circuit. If the turbocharger fails, the turbine bearing is often destroyed, which in extreme cases could allow large amounts of engine oil to enter the intake manifold. In this case, black smoke may also occur if there are oil leaks on the exhaust side of the turbocharger. Both indicate serious damage and require an immediate visit to a repair shop before the engine or catalytic converter is damaged. The latter, due to the precious metals it contains, can cost several $100s to replace. Black smoke. Too much fuel is being burned. If an old diesel engine smokes, it's no big deal. That's the popular saying. Being compression, ignition engines, diesels do not require a throttle valve to control the load, to accelerate, like gasoline engines, since it is not the volume of air that controls it, but the amount of fuel injected. In short, during intake, the maximum amount of air always enters the combustion chambers, where it is heated so intensely due to high compression that small amounts of fuel, injected at just the right moment, Trägerkombustion. Therefore, more fuel means more powerful combustion and, therefore, more engine power. If this amount exceeds the correct ratio to the intake air, the fuel can no longer burn completely and ends up in the exhaust as a sooty, oily residue. Incidentally, turbo diesels are so popular and efficient for the same reason. If I can't increase the amount of fuel injected, I simply increase the amount of air. A relatively small amount of fuel is called a lean mixture and produces particularly hot combustion, An excess of fuel cools the combustion and produces excessively rich combustion. Over the years, injection quantities have become increasingly controllable, so excess soot has continued to decrease. What remains accumulates in the particulate filter and is burned there in a controlled manner, as usual. If a modern diesel engine continues to emit black smoke, it is a sign of a problem with the mixture formation. The cause can range from a completely clogged air filter, where the lack of air causes the fuel ratio to be too high and the injection quantity can no longer be reduced, to faulty sensors. In the long term, this leads to an oversaturated or defective particulate filter, so this problem must be solved immediately. Since today's gasoline engines also mainly use direct injection, this can also lead to an increase in the fuel ratio and, consequently, soot formation. Another special case is related to the scenario mentioned above, damage to the turbo with oil entering the intake. In diesel engines, this causes a very dangerous effect, often referred to as runaway. Spilled oil is sucked into the engine and burned. This causes the engine speed to skyrocket uncontrollably, consuming more and more oil. An uncontrolled chain reaction that ends in a violent explosion if the engine is not mechanically shut down in time or the air supply is cut off. White smoke. Water is involved. You may have wondered why a combustion engine always produces a colorless, white, transparent cloud when starting from cold or simply in winter city traffic. This is completely normal and, to date, the least harmful form of exhaust smoke. It is water evaporating. It simply enters the combustion chambers along with moisture from the air. If the air is very cold, its water components survive through the engine intake into the combustion chamber, where they evaporate without causing damage. The effect is even more noticeable when condensation evaporates in the exhaust system. If the exhaust system cools down completely overnight, for example, the cooling air condenses on the cooled metal. This is why water often drips from the exhaust pipe after a cold start. Once everything reaches its operating temperature, the vapor disappears. What if it doesn't? Then it's water, which really has no place in the combustion chamber, it's coolant. This can happen if the cylinder head gasket is defective. This gasket is a sensitive component that seals the cylinder head, essentially the lid of the combustion chamber, to the engine block. Logically, this gasket has a hole for each cylinder, but also for the oil and coolant channels needed to supply the complex cylinder head. The boundaries between these channels and the cylinders, and also between them, are usually very narrow. Therefore, even minor damage, such as excessively high combustion temperatures or slight distortion of the cylinder head, can be enough to cause an undesirable mixture of air, coolant, and oil. The coolant then evaporates in the combustion chamber and produces white smoke, which, incidentally, becomes increasingly dense and noticeable depending on the severity of the damage. Therefore, it is not a big problem to drive to the workshop with an imminently damaged cylinder head gasket. Other signs of a defective cylinder head gasket include coolant overflow due to combustion pressure entering the water circuit. This can also be seen in severely swollen radiator hoses. If oil enters the coolant, or vice versa, it leaves traces, oily streaks in the coolant or a kind of foamy milkshake in the oil because an emulsion is forming, like mayonnaise. Grayish-white smoke with heat and a bad smell. Regeneration in progress. The last possible smoke color is not so rare nowadays. It is produced in a controlled manner when the particulate filter is regenerating. If possible, do not turn off the engine. Particulate filters have a honeycomb structure with a metal coating that allows soot to be filtered out. Implications for fleet management? To prevent smoke of any color from coming out of the exhaust, maintenance must be carried out according to the vehicle manufacturer's instructions and within the specified time frame. Smoke of any color coming out of the exhaust pipe means that the engine has a serious malfunction, and this usually occurs with engines that have high mileage, are old, or have been improperly maintained, emitting high levels of pollution. Companies and organizations are committed to reducing pollutant emissions, the greenhouse effect, the 2015 Paris Agreement, etc. So it is recommended that the vehicle be taken out of service and replaced with a new one. In a fleet of passenger cars or SUVs, it is recommended to have vehicles that are less than 5-6 years old or have less than 150,000 kilometers because they have the latest technology to comply with the latest pollutant emission regulations as well as safety standards. If the vehicle has colored smoke coming from the exhaust, it will not pass the vehicle inspection. It can be repaired and pass the vehicle inspection, but it will surely happen again with mileage or time, and in the end, it will not pass the vehicle inspection. Vehicles labeled with our company logos, such as taxi fleets, car sharing, city buses, street cleaning, etc., that emit smoke of any color, are giving our company a bad image because of all the pollution they are emitting on the street, which our customers and pedestrians can see and smell.
Learn about our fleet management consulting and training services. Reduce costs and optimize fleet management activities. We electrify your fleet of vehicles. We carry out the electrification plan until its implementation, known as